So we're going to start talking about rational functions. So rational functions can be formed when you basically have a polynomial divided by a polynomial. So what you see up top here, that's going to be the general form. And this is for simple rational functions, where the top part is basically just a number. We'll get into more complex polynomials on the next page. In this setup, we have a over x minus h plus k, where a is a number, x is your x, and h and k will be your asymptotes. So an asymptote is a line that you can't cross. So if you look at this diagram, y equals k is the horizontal line, x equals h is the vertical line, and this rational function has something in this quadrant and that quadrant. If you make a be negative, then you're going to go ahead and flip because you have a reflection. So the way to do it is to first graph the two asymptotes, then you're going to plot points to the left and right of the asymptote. Then you're going to draw two branches of the hyperbola so they pass through the plotted points and approach the asymptotes. So let's take a look at this first example. So I have negative 4 over x plus 2 minus 1. For this one, I'm going to first name the asymptotes. So again, I'm thinking about that h and that k. So if I come back up to here, I'm looking at x minus h, where whatever h is, that's the asymptote. So if I see a positive 2, my asymptote is at negative 2. So one of my asymptotes is x equals negative 2. I'm going to go ahead and draw that line right now. So I'm going to find negative 2 on the x-axis, and I'm going to go ahead and draw that vertical line. Remember, x equals a pure number is a vertical line. So this strip going down, that's my asymptote. I'm now going to go ahead and grab light blue. Do that for my next one. And my k value, that's negative 1. Coming back to here, it's plus k. So my next asymptote is at y equals negative 1. So for that, I'm going to go ahead down here. I'm going to find negative 1 on the y-axis. Go ahead and make that horizontal line. Okay, so this one here is y equals negative 1. And the one I did first, this is the x equals negative 2. Okay, so I know in the instructions it says I don't need a table, just make the graph. Well, to make sure that you understand clearly what we're doing, I am going to go ahead and make the graph, and then as you get better at this, you'll be able to just sketch the shape. So I'm going to go ahead right now and make an XY table. I'm going to do it over here. And so basically what I'm going to do is I'm going to begin plugging numbers in for x, and whatever I get out, I want to make sure I have some on this side, and I have some on that side. So I'm going to come through here and set it up on my calculator. So I'm going to use my fraction bar. I'm going to put negative 4 on the top. And in the bottom, let's go ahead and start with negative 3 plus 2. I'm ending with minus 1. So if you can see here, if I plug in negative 3, I'm going to get out positive 3. So negative 3, 3. So left 3 up, 1, 2, 3. Let's say I put in, let's go negative 4. And again, not all of these would be nice. I can skip some of these points. Let's see what we get. But this one is a nice one. If I plug in negative 4, I'm going to get out positive 1. So negative 4, 1. You can already see here that the shape of my graph is going to go down that way. But let's still add in some more points. I'm going to go ahead and put in negative 6. So I come back to here. That's a negative 6. And I get out 0. So negative 6, 0. Negative 6, 0. So again, these are the points that I have so far. And I'm going to go ahead and sketch those in now. So again, let me make these dots really nice and big. So the graph is supposed to curve as best we can. It is a sketch. Just make sure you hit those key points. Notice that it should be hugging at the bottom and hugging at the top, but not crossing and not touching. Okay, so if this portion was up here, the other one must be down below. So let's go ahead and fill in some points for that other part of the table. So looking at the right-hand side of this red line now, let's go ahead and plug in -1. So same function, just come back through, make it be a -1. When I do that, I'm getting out -5. So -1, -5. Let's go ahead and plug in -2. Actually, we can't use -2, sorry, other direction. Let's go ahead and plug in 0. -3. So if I plug in 0, I'm going to get out -3. Let's go ahead and plug in 2. If I plug in 2, I'm going to get out -2. That's what I just showed right here. Notice that I skipped 3. I skipped 3 because if I plugged 3 in, I'd have -4/5, which is -0.8, and it's fine. You could do that. It just will be as easiest for us as long as we try to keep them as integers or multiples of 0.5. You can use other values. It just might be harder to graph and harder to tell where is the best locations to plot. So again, this one here was from 2, -2. And let's go ahead and go out another. Let's go ahead and look at 4. 4 gives us -1.66. Not very nice. Let's look at 6. That's -1.5. That's okay. We can do that one. So 6 is -1.5. So 6. Again, this line is at -1, so -1.5 is right there. Let me go ahead and darken in those points. So again, this one here is 6, -1.5. This one is 2, -2. This one is 0, -3. This one is -1, -5. And I'm going to go ahead here and sketch this best I can. I am hugging the bottom of that red, coming back through, and I'm trying to get as close as possible to that light blue, but I'm not going to actually reach it. And again, that's what an asymptote is. You'll get very close, but you'll never actually reach. Okay, so now I'm going to go ahead and write in the domain and the range. Now, we've talked about in class different types of ways of writing domain and range. For this first question, I'm going to show you the different ways. After that, pick a method and go with it. So here will be my first method. So again, domain are all the possible x values. Notice that you can have anything but -2. So let's see here. One way to say this is just x does not equal -2. So if I actually let me use pen here. X does not equal -2. If you say that, it is assumed that it's all real numbers besides that one part. Let me show another way. Let's say we want to use interval notation. I'm going to write over to here, parenthesis, -∞, comma, -2, parenthesis, union, parenthesis, -2 to positive infinity. I'm using parentheses because I can't actually reach those values. I can't actually reach -2, and you can never actually reach an infinity. That's why these take parentheses. So whenever you have asymptotes, you can't actually reach those values. There's another one you could do. You could use inequality method. X is less than -2, and x is greater than -2. Notice here that I did not use equal signs because I can't actually get -2. So here are the three choices. X is not -2, tells you automatically it's all real numbers. And remember, this here is the symbol for all real numbers. So it's all real numbers but -2. This over here is interval method. Over here is inequality method. Let's go ahead and do the same thing for range. So thinking about my y values, what I can't have is -1. So I can say all real numbers, but y is not -1. So that's one method. Let me just keep switching colors here. I'm going to do interval method, -∞, up until -1, all parentheses, union, -1 to positive infinity. Again, I can't actually reach the -1, just sitting right here. I can get close, I can't reach it. And then lastly, for the inequality method, I can say that y is less than -1. That means going down. And y is greater than -1. That's a stuff going up, but never will I actually equal -1. So that's my first example. Let's take a look at this next one. So in this one, I have 3 over x minus 2. Okay, so my h value doesn't really exist. Remember, I'm looking for x minus h in the bottom. Well, if I don't see it, it means h is 0. So one of my asymptotes is x equals 0. That is a vertical line at 0, which is just the y-axis. So your y-axis, just go ahead, shade that in if you like. Make sure you can tell that this is one of your asymptotes. All the way up and down. For your next part here, we're going to look at that k value. So this means that y cannot be -2. Okay, just go ahead and fill that one in. So I'm finding -2 on the y-axis. Going to go ahead and draw my line. Okay, so I have two asymptotes. This one here was y equals -2, and that other one was x equals 0, which is just the y-axis. Okay, and again, because we're still new to this, I'm going to go ahead and have us make a table of values so our graph looks really nice. Let me go ahead and zoom in and adjust this. Okay, so let's come over here and make ourselves a table of values. So I'm going to pick something to the left of 0, do that side first, and then do stuff on the right of 0. So let's go ahead and choose -1. So again, plug in a calculator if you like. 3 over -1 minus 2. That'll give us -5. So -1, -5. Let's go ahead and plug in -3. Now again, notice that I'm picking values that'll make this fraction be nice numbers. If I plug a 2 in, yeah, it'll be 1.5, that's okay, but I'm going to try to avoid that as much as possible. So if I plug in -3, I'm going to get out -3. Okay, so you can already tell with this shape, I'm going to hug the blue and then come down and hug the red. Let's go ahead and plug in something else. I'm going to go ahead and plug in -6. So -6, and I'm going to get out -2.5. You know what? I'll take the decimal. -2.5. So -6, here's -2. This one here is -2.5. And let's go ahead and begin kind of curving that around. So again, these points I found give me the shape of the graph. And when I sketch the rest of it, maybe I'm exact, maybe I'm not, that's okay. I want you to mainly know what this graph is supposed to look like. So again, I hug the blue. I'm now going to come down and hug the red, but not touch it. So because my graph was down here, my next one has to be up top, up here. So we just found these values by plugging in stuff that was to the left of 0, negatives. Time to plug in some positives. Okay, so looking at that same function, let's go ahead and start by plugging in +1. That gives me out 1. So 1 is on here. Let's go ahead and plug in 3. If I plug in 3, I get -1. So 3, -1. And let's stick with this pattern and go to 6. So if I plug in 6, I'm getting out -1.5. -1.5. So 6, here's -1, here is -1.5. And again, for now, I'm going to call that good. If we were in class, I might have you make more points, but for now, I just really want you to know what this graph is supposed to look like. Okay, so we've sketched our graph. Let's go ahead and do domain and range. And again, you can pick from which method you want to do. The easiest method is to use the reverse of this. Notice that the first thing I wrote is just the opposite of the asymptote, because it tells you that it's all real numbers, but that one thing. So that's what I'm going to do. My first one is going to be x is not 0. My range is going to be y is not -2. You can have anything else but that. And again, if you choose to use interval method, that's fine. If you choose to use inequality method, that's fine. Okay, so on the front page, we had that simple format where it's just a over x minus h plus k, where a was a number. Let's now look at a slightly more complicated case, which in basically one step, we're going to rewrite it to get at that same format we're used to. So in this example, we're going to look at ax plus b over cx plus d, where a, b, c, and d are just numbers, and you have those x's. So what we're going to do is we're going to use long division. Now, I want to be very clear about this. I'm using long division because in the future, you might have very similar questions that have a bottom exponent that is larger than x, like x squared, x cubed. In that case, you are forced to use long division. If it is just a binomial, x minus 3 with no number on the front, you could use synthetic division if you wished. Notice that this one over here has a number in the front. So you're either using long or you have to first solve this. I would say just practice long. It's useful in other cases also. And I'm going to show that process down below. So let me slide this up here. So again, I'm going to show long division for x minus 3 going into 2x plus 1. And let me go ahead and switch. I forgot I was writing in pencil. So I'm going to use x minus 3 over 2x plus 1. Okay, remember when you do long division, you're asking yourself, how many times does that first term go into that first term? X goes into 2x twice. So I now have a 2 right here. I'm going to go ahead and multiply that 2 to everything I see here. So 2 times x is 2x. 2 times -3 is -6. Go ahead and subtract. So I'm going to put minus sign, full parentheses. 2x minus 2x, no more x's. 1 minus a -6. Well, minus a negative is positive. 1 plus 6 is 7. And now I realize that I just made something look a little bit not as nice. Let me go ahead and scratch this out. I want to put the 2 over here. Sorry. Whatever term you get, put it on top of the similar term. So I got out a 2, put the 2 over there. Ignore that one. This 7 is your remainder. So I'm going to have 2 plus 7 over x minus 3. Okay? So 2 plus 7 over x minus 3. Let's go ahead and rewrite that up top. We're going to put the 2 at the very end, though, to match it up with the plus k. So let me again, I'm going to take this. I'm going to put it up here. So this equals 7 over x minus 3 plus 2. It now matches this form perfectly. Let's go ahead and identify the asymptotes. Let me zoom out a little bit here. Okay, so from the bottom, I can see that one asymptote is x equals 3. So put that on the graph. I'm going to find 3 on the x-axis and draw your vertical line. Okay, so this one here is x equals 3. And let's go ahead and do the next one. Y is 2. So the other asymptote is y equals 2. So come up to 2 on the y-axis. Go ahead and make your horizontal line. Okay, and so this one here is y equals 2. All right, let's go ahead and make our sketch. And again, for our purposes right now, I'm still going to have us make a table. I'm going to slide this up and put it right here. So x and y. And notice that I can use either function, but it's going to be easier to type in if I use the second one. So I'm going to have 7 over some value minus 3 plus 2. And for that first value, again, I'm going to check to the left of the asymptote, to the right of the asymptote. I'm going to do the right side first. I'm going to start by plugging in 4. When I plug in 4, I get out 9. So 4 and 9. Find it here, 4, 9. Let's say I plug in 5. Gonna get out 5.5. It is a decimal, but I can still take it. So 5.5 right here in the middle. Let's say I plug in 7, 3.75. So 7 is 3.75. Again, that's really not as nice. I might not really try to use that one in a moment, but we'll see what happens. I'm going to go ahead and plug in 10, and I get out 3. 10 and 3. So that's right here, right on that intersection. So I'm going to go ahead and try to connect those as best I can. And again, our goal is to make these curves as smooth as possible. So I'm going to say I'm going to be hugging that red. Maybe not yet, but I will be eventually. Going through that point there, and I'm coming down. Now, I can't get any closer to the blue. It's really going to be like happening off the page here. But you can still see the shape of this. And this should be a smoother curve than what I've given it. So anyway, this is the general shape you're looking for. Okay, let's go ahead and do the other side. So let's go ahead and plug in 2. So coming back through here, 7 over 2 minus 3 plus 2, and I get negative 5. Again, I plugged in a 2. So 2, negative 5. Let's go ahead and plug in a 1. I get negative 1.5. So 1, negative 1.5. Okay, let's go ahead and plug in negative 1. Negative 1 gets me 0.25. So again, not the nicest of values, but I'm recording it for now. Let's go ahead and try negative 4, and I get out 1. So negative 4, 1. And we could keep going if we want it. Let's see here. Another nice value. What else could be nice about this? Let's try what negative 6 is. Don't really want to use that. Let's try negative 7. I could try that one. If I do negative 7, I'm going to have 1.3, which is pretty close to 0.25. So again, this is what I mean by saying that what we have is not going to be exact. Okay? It's enough to see the general shape. Let me come through and darken those points in. So something here, there, here, and there. So again, this one's going to get as close as we can to it. This one's going to start this curvature. Okay, so again, this is not perfect, not by any means. It's a sketch. Ideally, I'd be doing this in pencil so I could erase it and fix it. Unfortunately, I'm doing pen so the camera picks it up, so it's not the best. Okay, so now my domain and range. Again, the easiest way to do this is just use the reverse of the asymptotes. It is all real numbers, remember? All real numbers, except x is not 3. The range is all real numbers except y is not 2. Everything above and below 2, everything to the left and right of 3. Let's go ahead and take a look at one more example. Sliding this down. In this next one, I have 2x plus 1 over 4x minus 2. Again, notice that top and bottom, they both have x values. Let's go ahead and do some division. So I'm going to go ahead and show that down below here. And I am using long division. I have 4x minus 2 going in to 2x plus 1. Okay, so as I take a look at this and I say, all right, well, how does it go in? Notice that 4x does not really go into 2x, at least not cleanly. You will have two choices. You can either factor a 2 out of this first before dividing, or you can deal with it later. I'm going to show you the method where I deal with it later. It just means you have to be comfortable using a fraction for a moment. All you want to recognize is that if I multiply 4x by 1/2, I am going to get 2x. So that's what I'm going to go ahead and use. I'm going to use 1/2. 1/2 times 4x is 2x, because I'm just saying take the 4, divide by 2. 1/2 times -2, well, that's just -2 divided by 2, which is -1. From there, go ahead and subtract top line minus bottom line, just like you would in normal division. The 2x's are gone. 1 minus a negative means plus, so 1 plus 1 is 2. That's my remainder. So 1/2 plus 2 over 4x minus 2. Now notice that I can divide top and bottom by 2. Let me go ahead and rewrite this full line. 1/2 plus 1 over 2x minus 1. Again, I got the 2x minus 1 by saying take this, divide by 2, take everything here, divide by 2. That's how I got that. I'm going to take this and I'll put it at the top of my page next to my original question. But I'm going to write it in this order here, just like I did over there. So this equals 1 over 2x minus 1 plus 1/2. Okay? From there, let's go ahead and set this up for our asymptotes. Now, this is where things are just a little bit different. An asymptote, as you've said so far, is when we have this here with that x minus h. Well, there's another way to talk about this also. What I'm looking for is finding out when does the bottom go to 0. So up until now, that was sufficient. But technically, it doesn't matter what number's on the front of it, because if that goes to 0, I found the asymptote. Think about why. You're not allowed to divide by 0. It's not possible. So because you can't divide by 0, if this thing goes to 0, that's where the problem is. I'm going to go ahead and show that at the very bottom down here, I want to figure out when does 2x minus 1 equal 0. So add 1 to both sides. 2x equals 1. Divide by 2. X equals 1/2. If I plug 1/2 in, I will get to 0. That means my asymptote is x equals 1/2. And in this case, my y asymptote is also 1/2 from out here. So coming back down to here, y equals 1/2. Let's go ahead and put those things on the graph as best we can. Now again, this might be not the nicest one to draw. We're still going to try here. So here's 1/2. I'm going to put down some 1/2 marks and try to use that to line myself up. Okay, so that's x equals 1/2. Let's come through here this way and do it over here. So here's a half, here's a half, here's another half. Again, trying to get those things lined up as best we can. Okay, so those marks are the 1/2s. All right, so let's go ahead and make ourselves a table of values. I'm going to give you a word of warning. This table will not look pretty. Out of all the graphs we've done so far, this one will be more of a sketch than the other ones. So let's go ahead and make ourselves a table down below. X and Y. Okay, I'm going to go ahead and start by plugging in 0. So I'm going to have 1 over 2 times 0 minus 1 plus 1/2. If I plug in 0, I'm going to get out negative 0.5. Okay, not bad so far. Let's say I'm going to plug in, negative 1. If I plug in negative 1, I'm getting out 1/6, which is 0.17, and I am rounding right now. Let's say I make that -1 become a -2. So if I plug in -2, I'm getting out 0.3. Let's say I plug in -3. I'm getting out 0.36. So notice that these numbers are still very small. Let's jump ahead a little bit. Let's jump to 0.6, or -6, sorry. If I plug in a -6, I'm getting out 0.42. Let's go all the way to the end and pick -10. And I'm getting out 0.45. So -10 is still 0.45. So let me go ahead and put those values on the graph as best I can. Again, you'll notice here that it's not going to be very pretty. So 0, -0.5. So that's right there. Then I have -1 at 0.17. I have -2 at 0.3, 0.42, 0.45. So again, -6 is at that 0.42. -10 is at 0.45. So this one is a really, frankly, quite an ugly graph. So I'm going to try to sketch that as best I can here. And I'm just doing it in pencil right now. There's really no good way to graph this one. So if this is the one question you just don't get, that's okay. So be it. It's basically hugging this the entire way. It's kind of a hard thing for me to show right here without the lines actually crossing. Let me try to go over it with a black marker. And ideally, this would have been a larger graph, but unfortunately, it was not. So again, it's really hard to tell. It's okay. And if we do the same thing on the other side, the exact same thing will happen. I'm not going to bother taking you through the trouble of working with these decimals. Again, they're going to be really small numbers. I am going to try to give you the sketch, though. Basically, the exact same thing. It's going to hug it pretty much the entire way. Super close. Really hard to tell. That should have been a better curve. I'm going to try to get as close as you can out that direction. Okay? So ideally, they look the same. I'm not pretending to be an artist here. It's not the best, but you can get the feel for what's happening. So, what do we notice from this in terms of domain and range? Well, again, your x values, this direction, your x values are everything to the left of 1/2 and to the right of 1/2, but not at 1/2. So x is not 1/2. My range, everything below 1/2 and above 1/2. So y was not 1/2. From this final question here, what I want you to really take out of it is just more practice with the long division and simplifying it. Because this graph was definitely not the nicest thing to work with.